All right, we're going to continue in with example number 4, C, D, and E. This is from section 6.3. We've been talking about least common multiples, which is going to help us get common denominators eventually. These ones are a little bit harder, a little bit different, so let's look at these, finding a least common multiple. I have the term 12x, I have the term 15x cubed, and I have the binomial x plus 1. A little bit tricky because that one's a little bit different. We're going to do the same thing that we did though in the last video. We're going to break them down into factors. So what prime factors does 12 break into? 2 times 6, and 6 breaks down into 2 times 3. So I have 2 times 2 times 2 times that x, right? All right, I'm going to do the same thing with the 15. 15 breaks down into 3 times 5, and then I have 3 x's. You can write them all out if you need to. The last one's kind of tricky. It's not an x times a 1. It's really one term, two terms added together, connected with a plus or minus sign. So you remember those parentheses that we like to have, kind of showing that they're connected? Really, it has an x plus 1 as one whole factor. I know it has two pieces, but really it's just one factor connected with that plus or minus sign. So it really helps me to put those parentheses. Now, everybody needs the same stuff. So we need to figure out what we need to multiply by each piece so they all have the same factors. Now, let's see. The first one has 2's and a 3, but what number is it missing that the other ones have? It looks like it's missing a 5, isn't it? So I need to make sure that I multiply it by 5. It's also missing a couple x's. The middle one has 3 x's. The first one only has 1, so I need to give it 2 more x's. I need to give it a 5, I need to give it 2 more x's, and I need to give it an x plus 1. Now I can't just add 1 to the x. I need to be able to multiply it so that they're factors of multiplies, right? So x plus 1. So this one needs a 5, it needs an x squared, and it needs an x plus 1 factor. What does the middle term need? It has a 3, it has a 5, but what number is it missing? Well, it looks like it's missing 2 2's, right? So it needs 2 2's. It already has 3 x's, so it's good there. But it does also need that x plus 1 factor. It needs 2 2's and the x plus 1, so it has the same stuff as everybody else, the same factors. All right, what does the last one need? Well, really, the last term only has an x plus 1 factor, so it needs a lot of stuff. It needs the 2 2's, it needs a 3, it needs a 5, so that everybody has 2 2's, a 3, and a 5. It needs 3 x's, so an x cubed, and then it already has the factor of the x plus 1. So now that everybody has the same stuff, what's their common factors? Well, it's the 2 2's, the 3, and the 5, which really makes up 60, if I do 2 times 2 times 3 times 5. It has my 3 x's, and it has my factor of an x plus 1. 60, x cubed, and an x plus 1 would be my least common multiple. Kind of tricky. Be careful with that x plus 1. I know that's kind of a hard concept to think about. All right, look at D. I have an x squared plus 5x minus 6 and an x squared minus 1. This one looks a little bit different because it's hard to figure out what their factors are until we factor them, right? And so let's factor both of these polynomials. The first one looks like a basic factor. The second one looks like a difference of squares. So we can break it down into its factors. The first one, I factored incorrectly. This should be an x minus 1, shouldn't it? X plus 6, x minus 1, multiplies to a negative 6, but adds to 5. I just made a mistake. Okay, so make sure that's a minus 1. The second one factors into an x plus 1 and an x minus 1. So let's see what I have as their common factors. If everybody needs the same factor, the first one has an x plus 6 and an x minus 1. But what factor is it missing that the second one has? Doesn't it look like it's missing an x plus 1? Look at me messing up. An x plus 1, right? So now it has an x plus 6, an x minus 1, and an x plus 1. Okay, so now what does the second one need that the first one has? It has an x plus 1, an x minus 1, but it looks like it's missing that x plus 6. So now that everybody has the same stuff, the same factors, their common factors, their least common multiple, would be the x plus 6, the x plus 1, and the x minus 1. Now they have all the same stuff, same common denominator if they were denominators. All right, last one, trying to trick you. This first one has an x squared plus 4. Be careful, that cannot be factored, so that's it. They're connected with a plus or minus sign, so that's one factor. The x plus 1 can't be factored. It's connected with a plus or minus sign, so that's one factor. And then we have a 5. So really, these are all factored already, and if everybody needs the same stuff, then everybody would need everything else that it doesn't have. What I mean by that is this one would need a 5, and this one would need a 5. This one already has a 5. This one would need an x plus 1. This one would need an x plus 1. This one, middle one, already has an x plus 1. This middle one would also need an x squared plus 4, and this last one would need an x squared plus 4. Every one would need the other two things that it doesn't have. Does that make sense? Hopefully. So my common multiple would be the 5, would be the x plus 1, and it would be the x squared plus 4, because none of those can be factors. They are its own factor, and since they're all single to begin with, they all need everybody to be a common factor. Everybody needs the 5, everybody needs the x plus 1, and everybody needs the x squared plus 4. That one was kind of tricky. All right, we'll do a last example, example number 5, in the next video.